Good morning to all. Myself, Yashwardhan Reddy. I am from CSC branch. Today, the topic is about construction of working of H2O2 and CH3OH2 fuel cells. That means the topic is about fuel cells. Okay. Uh, we we further discuss that preparation and construction working about H2O2 and CH3OH2 fuel cells on next slide. How do we construct H2O2 fuel cells and construction? How we will make? First, we required two platinum electrodes or graphite electrodes, either we availability. Next, electrolyte. We use either KOH or H2SO4 as use possible or as you supply. Okay. On left side, hydrogen supplied to anode. That means construction cell hydrogen is supplied from left side, oxygen supplied to the cathode. On right side, oxygen supplied to the cathode. Separators allow in fluid flow. Purpose separator ions flow is the purpose. External circuit completes the fuel cell. Next, we see the diagram and reactions. This is about the hydrogen H2O2 fuel cells and with neat label diagram. On left side, hydrogen supplied to the anode. On right side, oxygen supplied to the cathode. Right side cathode and left side anode are prepared. On middle of these electrodes, water is added. Ion exchange resistance impressions with KOH. You will use able H2SO4 or KOH. Now at the anode reaction, H2 and 4 at the anode reaction, 2H2 plus 4OH minus gives rise to 4H2O. That means water and electrons. At the cathode, O2 plus 2H2O, oxygen plus water plus electrons gives rise to 4 OH minus ions. OH minus ions. Net reaction. Net reaction that 2H2O plus O2 gives rise to 2H2O water. E cell. E cell of the H2O2 is 1.23 volts. Okay, next we move to the next slide. H2O2, how it will work H2O2 fuel cells. That at the anode reaction, we saw already in the diagram. At the anode, 2H2 plus 4H plus gives plus 4 electrons. At the cathode, O2 plus 4H plus gives rise to 2H2. Overall cell reaction, the charges will cancel and then we will get 2H2 plus O2 gives rise to 2H2O, water plus electricity plus heat. This is about hydro H2O2 fuel cell working. Next, CH3OH O2 fuel cell construction. Okay. PTRU, platinum rubidium catalytic at anode, platinum at cathode. Proton exchange membrane, PEM, that means aqueous methyl sulfide supplied to anode. Oxygen or air, we call oxygen or air, supplied to the cathode. On right side, methanol is supplied. On left side, oxygen or air is supplied to the cell. Proton exchange member allows H plus ions to move to the cathode. We will see in the diagram. Okay. CH3OH oxygen fuel cell with neat label diagram and reactions. On left side, we anode. On right side, we cathode. They are prepared. See this, oxygen is supplied, CH3OH with parents of H2SO4, or you will take KYS solution. Oxygen is supplied, CO2. In between these rods, CO2 is prepared. CO2 is constructed platinum electrode and membrane in this diagram. At the anode reaction, methanol plus water, that means CH3OH plus H2O gives rise to CO2 plus 6H plus ions plus 6 electrons. This is at anode reaction. At cathode reaction, oxygen plus 6H plus 6 electrons. gives rise to H2O, water. Net cell reaction, CH3OH, methanol plus oxygen gives rise to CO2, carbon dioxide plus water. EMF of the CH3OH O2 fuel cell, that means methanol oxygen fuel cell, EMF is 1.121 volts. Move to the next. At the we see how it will work. At the anode reaction, methanol plus water gives rise to carbon dioxide plus H plus ions and 6 electrons. This is excess of electrons. Cathode reaction, oxygen plus H plus 6 electrons gives rise to water. Overall cell reaction, the both charges are cancelled. We will get methanol plus water gives rise to carbon dioxide plus water plus electricity. This is about working of methyl CH3OH and O2, methyl oxygen fuel cells. Then, now we will see comparison between both cells, that means H2O2 and CH3OH fuel cells. In H2O2, hydrogen will available. In CH3OH, methyl will byproducts water and H2O2. In these CH3OH, carbon dioxide plus water will available. Catalyst, we use platinum at H2O2, platinum rubidium at CH3OH. Efficiency is high at H2O2 fuel cells. Efficiency is moderate at methyl oxygen fuel cells. Thank you. This is Yashwardhan Reddy from CSCXF section. Thanks for this opportunity.